that Becquerel discovered discrete bumps, discrete blips, one at a time, and not night ultraviolet, shorter wavelengths, X-rays, and gamma rays. Gamma rays are just exactly these objects here. Very, very short wavelength, extremely short wavelength radiation. And that's what Becquerel had discovered coming out of there. The only trouble is that Becquerel discovered discrete bumps, discrete blips, one at a time, and not nice continuous waves. Okay, that then brings us to the puzzle of quantum mechanics. Now, we're not going to go into it in any great depth, certainly not tonight, but let's just recount the history a little bit. Einstein and Planck realized, for reasons mostly thermodynamic properties of light, that Einstein, that light had to be thought of as being made up out of discrete, indivisible elements. He might have been an experimental. In fact, in some sense, Becquerel's discovery was an experimental discovery. It's just he didn't realize the thing he was seeing was electromagnetic radiation. So I won't go through the actual history, but let's make up an imaginary history of how the discreteness of light might have been discovered. It could have been discovered this way. You, again, shine your light on a screen. And you illuminate the screen. And of course, what you see is a nice continuous blob of light. It could either be an interference pattern, or it could just be a single hole, in which case it would just be a blob on the screen. Experiment differently. Source of light, you put an obstruction in the way. The obstruction is a filter. The obstruction is not a filter, but a semi-transparent, semi-opaque thing which blocks out a certain percentage of the light. What happens over here? Well, the blob gets dimmer. Okay? It's not as intense. You make it thicker. It's even less intense. You see less light arriving per unit of time. And even a little bit thicker. And at some point, all of a sudden, the character of what's here changes. And instead of seeing the blob, you see discrete events, little blips. Over time, these little blips build up. And they build up to something which has exactly the same pattern as the blob had. So the blob in this case, then, is some sort of effect that has to do with lots of little blips, so many little blips that you can't recognize them as being individual. That's the blob. But if you attenuate the light and cut it down so that the intensity coming through here is really, really small, what you see is blips. This experiment can actually be done. It was not done in those early days, but you can imagine. And this is what Einstein had suggested really does happen in his photoelectric paper, through as absolutely discrete things. The motivation for it was thermodynamics and other things, but this might have been the form of discovery, discovering these individual blips on the screen. And this is what really would happen. So, something very, very confusing going on. Light is a wave. That had already been proved. In fact, if we put a screen over here with two little holes in it, we will again see light coming through bit by bit. And if we leave it up there a long time, the blips will sort of fill in, and what they will form is an interference pattern. So it became clear that clear but still very confusing, that light is made up out of indivisible elements called photons, and that the wave character of the light really represents, or the wave pattern really represents the probability that the photon appears at different places. In other words, it's randomly arriving blips, but they arrive with a probability in different locations, which follows the pattern. The wave theory gives you a wave theory of probabilities. That's quantum mechanics. We will have to talk about quantum mechanics a great deal more.